So I welcome in my virtual studio Michal Szczepanik, and Anton, who will help me moderate this talk. Michal, Anton, hi guys.
Hello.
Hello.
So how are you? Have you seen Simon's talk?
Yes, I personally yes, and it was awesome. Let's say so. Generally, Java new versions of Java introduce a lot of the features. Of course, as it was mentioned in the chat on YouTube, a lot of these features we know from different languages, and some people mentioned that they were in Kotlin from years. But come on, Kotlin is also the language which almost copy paste some features from different languages to make our lives better. So it's good that we have this improvement, and generally without that, on the Java level, on the JVM level, we are rather not able to move forward with other languages, like for example Kotlin, in case of JVM support.
Yeah, and let's say that Java is nearly 30 years old, and Kotlin is, like, let's say, nearly 10. So I think everybody
Really,
is.
nearly. Yeah.
Yeah. Okay. Anyway, could you tell us a few words about your talk and what it will be about?
Okay, so in case of my talk, it will be about different languages in JVM world. So I will cover a little bit Java, but we had good talk previously, so it will be not a lot of Java, but more Kotlin, Scala, and Groovy. So I will discuss about the features which we have in these languages and when we can use these languages to solve some problems which for which they are created. Yes, to make better way of writing the solutions, because in one language, I don't know, choose something different like C++ to not be on Java level. We need to write thousands lines of code, and the same in Python is one-liner. So come on.
Yeah,
We
I
have
would
these
summarize it.
situations.
I would like to summarize it like it's better to use more languages than to hate other languages, right?
Exactly. Yeah.
Okay, Anton, I have a question to you. Which languages do you use from GTK world?
Usually I use Java, and actually we write tests on Groovy, and it's really awesome. Groovy is a awesome language for tests.
Nice, nice. So, I've never heard, to be honest, that it's better to write tests on Groovy. So probably I need to check that as well. So yeah, nice catch, by the way. So, and what do you think about Kotlin and Scala? Anton?
I love Scala, and also I love Kotlin, but I never use them, unfortunately. Maybe
Okay.
after this talk, I will think about it.
Yeah, just try them. So you would have your own opinion at least about that. So Michal, question to you: which languages do you use in your real work? Like all the languages which you will talk about
Okay,
today?
so this is, let's say, limitation of my platform, because on daily basis I am a mobile developer, works mostly with Android. So in Android world, let's say, work without Kotlin can be a little bit difficult nowadays. Of course, there is option to write the code in Java, but we are talking about the Java 8. Okay, the last Android provides some features which allow us to use some features of JDKs from higher levels of Java, but still we are limited to Java 8, which is a little bit problematic. But as I see, I am not alone, as more than 50% in the poll report that they still are using Java 8. So come on, in the world where we have stable version 16 is a little bit strange.
Well, I would say, like from my side, we use on project Java 11, and not so far ago, I tried to migrate our project to Java 15. So that was December. So there wasn't Java 16 at the moment, and I couldn't do that because one of the libraries which we use in our dependency, as far as I remember, it was Spring Cloud. They did not support Java 15 at the moment. After a few weeks, they released like the new version which supports, but like it could be a bit problem. But I would agree that if you use like Java, I think Java 11 is a great chance to use something new, because like it's long time support version. So if you use Java 8, try to consider using Java 11 at least. And yeah, and we will have Java 17 in September, so that's also a good point of all this stuff.
Exactly.
Okay, I think we may go like closer to your talk. Before we do that, I want to say that we'll have special Telegram chat for the questions for Michal, and please have a look at this Telegram chat. The links would be in our main Telegram chat and in YouTube chat shortly. So join this chat, pass there your questions, and we will try to ask all these questions to Michal. And of course, after the talk, there would be discussion room, so you would be able to discuss all these questions closely with our great speaker. So, saying this, Michal, good luck with your talk.
Okay, thank you very much. So, hello everyone. Again, my name is Michal Szczepanik. I am Chief Software Engineer at EPAM. And the talk will be about the power of JVM languages, or Lang. Generally, we discuss about the power of the bytecode, which we generally allow us to do this, all these funny things with Langs, or we are talking about the Langs in which we are writing the code. And as I mentioned just before the talk, I will cover Java, Groovy, Scala, and Kotlin. But as we are in Java world, probably most of you had this moment in your life that some recruiter call you and ask about knowledge, not about of Java, but the JavaScript. As you know, Java probably is enough to for you to learn JavaScript, to learn script, and then you know the JavaScript. They totally don't understand the difference that this here we have totally different slangs. So let's do this for the last time and explain why we shouldn't use JavaScript. Come on, this slang is a little bit crazy. So first questions from the JavaScript world. This code which we see on the screen, what will be printed by it? Some clue, they will like it. And the answer is banana. So why banana we will discover in a moment, but let's go through other JavaScript codes. So in JavaScript world, we have array plus array. What will be the output of it? Generally, what do you expect as the output of array and plus array in normal lang? Maybe array, it makes sense, but no, we have JavaScript here, so the answer is empty string. Okay, so let's go to the other example. We have array plus object. So what it can be? Array of objects? No, it's object. So okay, it's object. Can be somehow. But we have plus here, yes? And as we know from math, plus and order here doesn't matter. So we can switch the order and we should get the same, yeah? But come on, we are in JavaScript world. So what is object plus array in that moment? It's 0. So the last question, what is object plus object? Let's think for a moment. And I think that the answer from JavaScript is the only true statement here, because the answer is not a number. So I have no idea what we can do with this lang if we have these beautiful solutions in it, and what was in mind of the person who designed this language. But come on, it's a little bit insane that we have these types of structures in the JavaScript. So back to our banana sample. In this example, we have the case which we can evaluate like that. So we have this kind of structure. So in here, JavaScript try to convert a to a number, because we have another plus operator here, and generally, because it cannot be done, it will return the not a number here. So that's why we will get the banana. But this is not JavaScript conference, so let's forget about this lang. And please, recruiters, please don't call me and ask about JavaScript knowledge. So we are in Java world. We are in JVM world, in which we can do a lot. So we can use Java for web development. We can use Java in many frameworks for big data, for continuous integration, and in totally different virtual machine, because the Dalvik virtual machine on Android. So as we can see, the opportunities for usage, Java usage, we have in many places. So we have not only Java here, because all these languages which you see on the screen can be compiled to the Java bytecode. And generally, when we have the code of them, they use the same bytecode. So we have some limited number of instructions, more than 200 right now, which limit us to create some amazing code. So not all the features we can introduce in this world, because we have limitation of the bytecode level. So, for example, some features of Kotlin, which we have when the Kotlin start, were really improved, because we get the we get the better JVM support for some of them. So it's really good for us to have the new versions of Java, like Java 16, even from perspective of all these langs. And the big plus of JVM and Java and all these langs is that we can switch between them. They can cooperate with each other. So we can use Java. From the Java code, we can call Groovy script, or we can use Kotlin code together with the Java code. And in case of these two langs, the cooperation is quite nice. So we can quite easily call Java code from the Kotlin code, and also from Java we can use the Kotlin solutions. Sometimes, of course, we need to use some annotations to explain how this structure, for example, extension function, should be visible from the Java code perspective, but this is quite easy. If we compare it to the way how we can operate with Java and Scala in one project, here we have really nice solution. From perspective of Java and Scala cooperation, we have this issue that, okay, we can quite easily call the the Java code from Scala code, but vice versa is a little bit problematic because some structures which you get on bytecode level in case of Scala are really complex and not easy to use directly from the Java code. But usually when we cooperate with this different langs, we use different modules and stuff like that, so we can quite easily isolate this problematic code somewhere under much nicer constructions from Scala. So let's back to the bytecode. As I mentioned, we have this limitation of the instructions here, and this code represent something which from Java looks like here. And generally, all these langs generate something like that. So we get the class files, which generally define the structure of each class, no matter what was the source lang which we used to define it from our code perspective. So in class file, first we have file format, and we also should inform which Java version we are supporting. So which Java version should be used to interpret this specific bytecode which we have later on. Then we have some info about types, so access flags, information about the name, superclass interfaces, fields, method signatures, etc., and the bytecode. And this file is our representation of our code in the JVM world. So after that, on JVM, we need to use class loader to load the classes. And in case of class loaders, we have hierarchy of them. So sometimes we may hit some problem that, okay, on this level, we load some class, but because of wrong loading and some different class which name the same, we can get this error that command this method cannot be found, or something like that. Mostly you should see it in let's say you should be able to saw it in JBoss a few years ago, because we have huge hierarchy of class loaders there. In case of class loader, we have few phases. So loading, which read the class file, and linking, where we have verifying, preparing, resolving, and initializing some static initializers. And after we load the class, the interpreter goes to work. So generally, interpreter interpret the bytecode and use some templates of the native code for this specific architecture of the processor. So we have different interpreter for Intel, for ARM processors, and convert the line of bytecodes to the code, to the native code for this machine, and also detect some critical hotspots in the program. That's probably the source of the name of Oracle JVM hotspot. Yeah, and after that, JIT is in use, which optimize our code on the go. If we discuss about high level how everything works. So if we have, for example, code which is run many times, JIT will optimize it and speed up this part of code. Of course, we have much more optimizations here, and they also depends on the JVM version which we are using, and Java versions. So So let's not go to the details, because then this talk will take 1 day, not 1 hour. And when we have different codes in different languages, for example, this code for Kotlin and this code for Java, which looks like they do the same, but okay, Kotlin is a little bit more concise and expressive. Of course, depends which Java you use, and also Kotlin version. And generally, both these structures from different languages on the bytecode level may looks totally the same. So as we can see, okay, from our lang perspective, we have nicer code, for example, here, but it will do the same stuff on the JVM and look the same on the JVM as the code from Java. So as we discuss about code concise, we should go to first law of software quality, which is here. So probably all of you know this from physics, yeah? Physics, that we have something like that. And when we go to the software, we can interpret it in a little bit different way. So the number of errors depends on our lines of code. So the best program is the program where we don't have lines of code. Come on, no code, no errors. But in real world, we rather need to write a lot of lines of code to solve our problems. And sometimes some of these langs may help us to reduce these numbers of lines of code and do the stuff in one-liner. So generally, someone solved this previously for us on the lang level, and we don't need to think how to solve some problems, because one lang can solve it in one line, and in other lang we need to write 200 lines of code. So let's go to the first problem, which was quite popular when the Kotlin comes to the game, is null pointer. So in case of null pointer, we should mention Sir Hoare, who designed the null reference in 1965. And generally, he created this reference because this solution was simple, because it was easy to implement. So he was probably lazy, as most of us programmers, yeah? So he chose the easiest solution to implement to solve the problem which he had during that time. And as we know, for right now, the null problem is called billion-dollar mistake, because we have a lot of nulls in real life, and we can see these issues in many places. For example, in my country, in Poland, you can buy a train ticket from Katowice to Null. It costs around 20 zloty, but I have no idea where the Null is in Poland. Probably there is no city or village like that, but we can buy the ticket. If you have phone in Orange, sometimes you can get the null message from them. So as we see, another problem. And imagine that your surname is null. As we can see, this was in it was a long time ago, more than 10 years ago, or even more for now. But generally, as probably most of you heard, just before this COVID problem started in the world, there was a girl from US who had surname Null, and she had a problem to fly outside of the United States because she's stuck in the system because the system cannot validate her surname because it was null, so it was wrongly interpreted by the implementation. So let's discuss about the first option which we have to solve the nulls. So in Java we get optionals for that. Even before Kotlin provides some features for that. And the same we had in Scala. But in Scala, we have these funny things that you can assign none to optional in Scala, but at the same time, you have same structure in which you can add null as an argument. And as you can see, this is not the same. So generally, we have three values in Scala for optional, in which both of them are a representation of the null type. So optional solve the problem? No. And this was, I think, the most popular solution of Kotlin when the Kotlin was introduced. It was the null safety. So in Kotlin, we have nullable types and non-nullable types, which means that when we have var, which is a string, and we try to assign a null to it, we will get the compilation error. And at the same time, when we would like to assign null to a little bit different type, everything works okay. So generally in Kotlin, we have two structures. One is non-nullable type, and the second one is nullable type, which looks like that. We have the type name and the question mark at the end. And then we can quite easily use nulls in this lang, and the IDE and compiler will check if we check that this object is not null. So we can use standard ifs, which we know from Java and other langs. So if b is not null, then do some operation, or we can use the structures like here, which is question mark and then dot, which means exactly the same as the line here. So first we check if b is not null. If it's not null, then we call this function. The other operator is here. So we have this nice structure which allow us to throw a null pointer exception when the b will be null. Awesome. Taken from Swift, I think. So as we can see, this is something totally not new in Kotlin. It was in Langs previously. And some people mentioned that, okay, this is the operator which is risky because it can throw exception, null pointer exception, etc., etc. But you have many cases when you know that this value cannot be null here for sure. So I really like this this operator because of that. Because after this line, till we don't change the b will be interpreted as non-nullable type. So we can use b without these crazy questions marks and checks for non-null after this line. Okay, the next operator is the Elvis one. If you take a look like that, you will see that, okay, here we have her and I, so we have Elvis operator, which works in in the way that if b is not null, okay, call the length. If b is null, return the value which is on the right, so return 0 in that case, and assign it to all. And this is the operator which also exists previously in other lang, which is Groovy, which we'll be talking about later on. And generally, now we can take champagne and because we solve the problem of null pointers using one of the langs. As we are talking about Kotlin, we should also mention for sure quite nice feature of it, which is extension function. So extension function is the function which we can create for some specific class, like for example for string here, and do the stuff which we need. For example, escape from XML in that example, and we can call this method from our code perspective exactly like the method of this class. So it's nice way to create utils, yeah. So we don't need to write the string utils in Kotlin because we have extension functions, and we use string. We use this structure in nice way. Looks like exactly the same like function of current class, but how it looks from the Java bytecode. String is final. Come on, we cannot inherit string. So from the bytecode perspective, no matter if the class is final or not, we have in real the static function which get the first argument, which is the class which we try to extend. So the problem starts here, because from code perspective, it looks exactly the same like any other method which we have in this class. And when we have inheritance, it works a little bit different when we have super and subclass than extension function, because of the way how the extension function is implemented on the bytecode level. So we have superclass and subclass here, and for both we create the same extension function. So the same name of extension function, show me, and one return the string super. That's the second one return the string sub. And when we create object like super instance, sub instance, everything is clear that here we have super, here we have sub. But when we create var, which is of type of super, but in real it uses subclass object. In case of inheritance, we really know what will be called here. But in case of extension function, which show me will be called the super one, because here the compiler see that this is super class object, and the same we have here because we cast this object to the super class. So the show me from super class will be called here. Another feature which we have in Kotlin is default and named arguments, which generally can reduce a lot of numbers of the methods which we have in our classes, because we can write one method and set some default values for some arguments. So for example, here we can call reformat only for string, and then all these values will be used based on default parameters, default values. So true here, false here. But in case when we would like to change one of them, we can use the name. So we don't need to use something like we know in C++. We know from C++ that we should then use all of them, no matter if we use even the same values as are the default one. But here we can use the name and assign the different value to it. So also, not a lot of the codes and generally named argument are sometimes useful. For example, if you are not using modern IDE, you don't know which parameter is which. So sometimes it's better to use name arguments in some specific cases. But okay, how this structure can be implemented on the bytecode level? We don't have something like that in Java, at least for most of the Java versions which we have for now. So the solution is quite funny because we have the method which take all parameters without these default values, and we have the second method which is also the method with all these parameters and the additional parameter which is integer. And integer is a binary map of which parameters I should use and I should change, and for which I should use the default value. So generally we have integer, and each bit define which argument should be used with default value and which one is assigned with different value. So this is how it's solved on the bytecode level, and probably someone will ask this question: what happened if I use more than 32 arguments in the function? I know that this is crazy, come on. But this is also solved in Kotlin. Then you have two integers, so two binary fields to represent the arguments. So generally, we are not limited for 32 arguments with that feature. Of course, we shouldn't use that, but still it works. And let's move to the next topic, which is known pattern or execute around method pattern, depends which naming you use for this. And this is something which we can also use in Kotlin to solve some problems using extension functions, expressions. So we use more features of the Kotlin to reduce the numbers of lines of the code. So here we have sample of the database usage. Yeah, so we have begin transaction. We do some operation on the database, set transaction successful, and transaction. And generally, sometimes we can see the same code in many places in your apps. And sometimes when during copy pasting, someone removed the set transaction successful, and we will spend hours or days on searching where the issue is. So to reduce this problem, we can use extension function. So we can create extension function for SQL database, which is called intransaction. And as a parameter for it, we can send the function which return unit. Unit in Kotlin is like void in Java. And we can call this function. So instead of this code, we can call for db intransaction, and inside it db delete, and do what we need on the database. But come on, here we have still copy pasting. And what happened if I have more than 2 dBs in one project. So I changed the name here to, for example, db2, and I forgot to do this here. So we have again some potential issue here. So we can solve it with some additional change in this code. Instead of function for which return unit, we can define that, okay, this function must be a function for SQLite database which return unit. And then we don't need to call this db here because the function will be used for this specific database which we set here. We can also then use inline to optimize code on the bytecode level a little bit, as we have lambda as an argument here, so we can quite easily play with it like that. And how to solve this problem in Java? Sometimes we have the situation that we have resources which we should release after we finish playing with this class. So we can consider finalize. So most of you who still works with Java 8, in Java 9, if I correctly remember, finalize was deprecated. So you can you have the deprecation of the overriding it. And generally, as most of us know, finalize is the function which is used when garbage collector remove the object. So it's really risky to put any business logic there. So we shouldn't use it at all. That's why it was deprecated also. And we have ARM in Java, so automatic resource management, which allow us to operate on the object in some interesting ways. So ARM allow us to use auto-closable interface, and then we need to define the close method for this class. And then this close method will be called after each try block for our objects. So we don't need to call the finally in our code in which the close will be called in our code. It will be done automatically. So we can imagine that we have finally block here and the close inside it. So no matter if we will have some potential error here and we catch the exception or not, the close should be called. But come on, we still need to remember to use try, etc., etc. So as we are lazy, maybe you can think about some different structure to do the stuff for us. So we have this pattern, execute around a method. Yeah, so we know this from try and ARM. Generally quite similar pattern we have when we discuss about synchronize. So generally we set a lock here, we release the lock here, and we do some stuff inside, same here. So execute around pattern we can implement in each lang which support lambdas. So generally we can create a class resource and private constructor for it, private close method, method operation, which we will use as a lambda to the function which is function use, in which we have consumer. So we can put all methods which we have for this publicly available for this object here and do the stuff. So generally we create the resource object, do the operation, and we are sure that we release our resources. So we can call this like here from our code quite easily. And as I mentioned, this pattern can be used in all langs which support lambda expressions. So the next problem, which we sometimes hit in JVM and Java lang, is the recursion. So as we know, we have function like factorial, for example, here, and each time when we operate on it, we will put something on the stack. So this can be a little bit problematic for us, because when we have huge n, we will see stack overflow in our program. So how to solve it? Here we have quite a nice solution in Scala, which allow us to optimize this code, but not this code like here, because we have some problem in the logic here, that we have n here, which we need to multiply by factorial of n minus 1. And come on, this relation shows that we cannot optimize this code. So we can try to rewrite this code in the way like here, and use the tail call, which generally, because we have the same method as a last call of our function, Scala will and we don't have this relation like we have here, because we use accumulator for that. Scala will optimize this code in the way that from code perspective, we see recursion, but from bytecode perspective, it will be working like a loop. So we don't have a risk of stack overflow here. This can be quite nicely solved in Scala. The same feature was introduced in Kotlin. And quite important fact is that we have this annotation tyrec, which not means that, okay, do this optimization for this code. You can remove this add notation and this optimization will still happen. But this inform compiler to check if this optimization can be done. So we will get the error if not. For example, someone will put some multiply or other stuff here, which not allow us to do this kind of optimization. The next nice feature from Scala is single abstract method, which generally allow us to create to override methods in nice ways. So generally we have traits here, and we can create object with specific implementation of this method like that. So in one liner, we don't need to write the code which we usually use, like override the and the function. So this is limited to one liner, and for example, we can quite nicely use it in threads. So we can override the run and do the stuff in separate threads. Okay, the next interesting feature of Scala is the left associative methods, which works like that. So when we try to interpret this code, we see it like that. And in a normal, in typical way, how we call the methods, we have dots here. And okay, this is something which exists for list, but can we create our own method like that? Of course, yes. And The only required fact here is that the name should start with a special character. So it cannot be letter or number. And then we can quite nicely use our operators like that. The next feature of the Scala is backed in names, which we can see here. So like in Java, in Scala we use getters and setters, but using backed in names, we can use this sign to write the code, to write the name of the method, and this goes that we don't need to write this sign, and we can use space. So we can quite nicely call our setter in the code in much more readable way, not something like that, which is the standard call. Also, multi-words methods and fields names allow us to set space in the names, and we can use almost sentences for the methods. Maybe in normal code is something which we rather don't plan to use, but in case of names for tests, it is really useful because we can write this almost the sentence which explain what the test is checking, and then we have quite nice documentation using our tests. Okay, so during the previous presentation, you had a lot of latest version of Java, but the feature of Java, which for me is missing in Kotlin, is this one. So we have access modifiers like private, protected, public, and the magic in Java is also package private, which allow us to hide the whole class or fields inside the package, and this allow us to really separate the logic and hide the logic of our implementation inside the package. So we can, for example, in the package create one public class and the rest of them hide as package private, which allow us to first separate the logic between bigger number of classes and generally hide our implementation, so no one will use it outside of our package. So we have only one class, which is a contract for the rest of the world. What is quite interesting in Scala, the package private modifier also allow us to define the hierarchy of the package. So allow us to, for example, make this class visible in a package above, but not higher, etc., etc. This is something which was really nice solved in Scala to allow us to nicely create the logic and encapsulate it inside the packages. Unfortunately, this visibility in Kotlin do not exist. And to be honest, for me at the beginning, when I started using Kotlin, it was a little bit a nightmare, mostly because in Android world, when the Kotlin was introduced, multi-modules projects were, let's say, not really good optimized. So they built much longer than the one module project. Right now, this problem not exists, let's say, from the build perspective, but still, for me, something is missing, and this is one of the things which I really don't like in Kotlin that this is not included there. Okay, so the next lang to discuss is Groovy. And Groovy as a lang is a scripting lang, so allow us to do a lot of the magic, and it's really awesome in tests. So we can really reduce the number of lines of codes in our tests to do a lot of the magic. One of them is, for example, JSON to class. So generally, we get some response, and using this nice structure, we can quite easily parse this text and convert to the object, which really reduce the numbers of lines of code or tools on which we depend on. So we only need to use Groovy, and to convert it back to the JSON is one-liner. So really, really nice feature of Groovy. Also, the generation of the XMLs in Groovy is work in a really interesting way. So generally, we have this markup builder, which we can use to build the XML, and as we can see, the code is really nice structure because of that. So we exactly see how the structure of the XML will look like after we run this code. In case of interactive processes, this is also something which is awesome in Groovy, how Groovy allow us to operate with them. And if you will try, for example, write the same code in Java 11, for example, you will probably need to use hundreds lines of code to make the same stuff. So in Groovy we can define the string with the name of the process, call execute for it, and then do anything what we would like to do with it. So, for example, get the text which was returned by our AP config or whatever else, or help for any method, etc. So we can do a lot with that. Also, we have this type of processes which require some inputs from us. So in that case, we still use execute, and then we can check each line, search for some specific text, which means that, okay, you need to provide some value later on, and provide this value. Maybe plain text password is not the best idea, but generally show what we can do with this with Groovy in that cases, and really reduce the number of code from different slangs, including Kotlin. And when we discuss about langs, and for sure we should discuss about the multi-threading. And in case of multi-threading or as async work, Kotlin introduced something which is called coroutines, which allow us to write the code in a really nice way, like synchronous code, but it runs in a really light way, which allow us to run the code on different threads. And based on the coroutines, we can do a lot of work. So we are not, first, what is awesome in coroutines that they are also called the lightweight threads because of the way how they works. They not block the thread, which sometimes happen when we need to do some synchronization between them. So in really old way, when we create the new thread for every computation, we had different threads, which caused that it was too expensive because each time when we create new thread, we take some resources. So it is problematic for us, and with that way, first we take some memory because each thread takes some memory, and additionally, when we have a lot of the threads, switching between them was really expensive from the CPU perspective. So that's why after that, when the executors were introduced, so we had fixed numbers of threads, and we are adding the tasks to the executors. But still, it was difficult to manage dependencies between the tasks. So the problem which we hit here was that the code, okay, was quite nice, but and do not take that much of resources, but all these callbacks and all this nightmare was a little bit problematic. So in case of coroutines, the computation can be suspended. So we have some job on the thread which require the solutions from different threads. So till the work which we need to done in the background is not finished, or we are waiting for something, we can suspend this task and allow other tasks to use the thread. So if we take a look how it looks in our old way, so we create two threads, and then we are idle here because we are waiting for the output of the threads. It was rather problematic in many cases. When we think about the RX more reactive work, we start playing with callbacks, which depends which feature we use for that. Was easy or really difficult to manage, or we create some kind of callback hells in our code. And with the coroutines, we really reduce this problem, because coroutines first run the task, suspend the job which we have on this thread, and when this task is finished, we are able to back to the same point in our program and do the rest of work. So we have this suspension and await structures, which are in general in coroutines, which allow us to do this magic and do not lock the thread from which we on which we require to get the value after we finish the task. What is quite interesting in case of the coroutines, in case of Kotlin, is that they are implemented in the way which use state machine. So each suspended function is separate state in the state machine of our program, which generally means that the coroutines code is the only code which we cannot, in my opinion at least, cannot write in Java for now, because we need to know some, we need to have some knowledge after the compilation. So the stuff which we know during the compilation of the program. So it's not that easy to write the same code in pure Java. It's easy on the, it should be doable on the bytecode level, but from the Java code till we don't know how the code will be compiled, it is rather difficult. So, so in case of multi-threading or asynchronous support, coroutines provides a really awesome feature to Java world. And this is also not something which is new. They were in .NET for a long time before Kotlin, in Kotlin. So, as you can see, during this presentation, I show you a lot of the features of the langs, which are not in others. But what you can see, generally, tasks which we have on our daily basis works not only require us to think how to write the code to solve this task, but sometimes also require us to think which lang I can use to reduce the code. Do not spend a lot of the time on solving the problem which is already solved in other lang which I use on daily basis. So as was mentioned just before this presentation, consider to use, for example, Groovy for tests. Also consider to use Kotlin for tests. Consider to use some Java structures inside your Kotlin program when you need to be sure that you need to, for example, hide something and you need, for example, this package private visibility. So there is a lot of features of the languages which we see here, which we do not consider on our daily basis work, but they are really useful, and we shouldn't hate. For example, the Kotliners shouldn't hate the Java because, okay, I can write this as one-liner in Kotlin when the other stuff, like for example, error handling, can be a nightmare for me because it's not supported by in Kotlin. So come on, each lang has some pros and cons, and we should consider the best one for our problem. And that's all from my side. Thank you very much.
Thank you very much for your great talk. It was just awesome. I really like it. So thank you very much for this great talk. Before we proceed, I want to highlight one more thing. So we have some guys and girls who was really worried that you don't like JavaScript and that you say a lot of not really good words about these languages in the beginning of your presentation. So, first of all, I want to say that we don't want to shame any languages here. So
yeah, of course.
We here want to just have fun time. So, and but some languages, I would say mostly every language has its own drawbacks, and that we here want to highlight these drawbacks. I don't think it's a so big problem. So, if we offend anyone,
maybe I will do the next presentation about for at JavaScript conference, and I will hate the Java structures or Kotlin structures, which make some issues. Yeah, JavaScript is sometimes funny as we see, but this is for sure a nice lang to do the stuff which we do with the JavaScript, and other langs are rather not that useful in that cases. So for sure. I would like not to hate the JavaScript here, and I like JavaScript as a lang when I need to use it, and in cases for which it was created for. Here we have Java word, and generally for me it's sometimes more irritating that some recruiters ping us, come on, do you know JavaScript? Do you would like to be JavaScript developers because you have Java in your CV? And still, this is quite funny that for some people, these two languages are the same or almost the same.
Yeah,
So,
but anyway, if we offended anyone, like you think that we offended anyone, so our apologies. We don't want
yes.
to offend anyone if you like use JavaScript or whatever. Okay, so guys, I want to remind you that we have special chat for questions. You may find it attached in YouTube channel, and also I want to remind you that we have common chat like for all conference, which calls Jacob. So I posted the link to the chat in YouTube. So Anton, I want to pass the voice to you if you have any questions.
Okay, thanks. I don't have questions. Your talk was pretty clear, and thank you very much. I enjoyed your presentation. And you told about some interesting Kotlin features like coroutines, and I really like coroutines, but also I hope that Project Loom will be a good alternative for coroutines. What do you think?
To be honest, difficult to say. Expecting yes, but what I can say, it depends. Yeah. So right now, still I see many people don't consider coroutines in their projects. So here we can have quite similar situation that it can be a little bit problematic, but it really depends. So it can be good alternative for sure.
Yeah.
But the last decision is rather on the developers, not on us to decide.
Yeah. Okay, and we have 1 minute. I think I can thank you for bytecode insertions. It was really good. Yeah, thank you. And
Thank you.
I think we can move to the discussion room.
Yeah, so thanks again for this great talk. Anton, thank you very much for your moderation.